Okay, well, welcome everybody. Thanks so much for joining me today. My name is Brandon Minnick, and in this session, we'll be talking about choosing the best AWS service for your website and your API. Now, I'm so thankful for being here today to be able to share this information with you because when I started at AWS a couple years ago, I went through this same exact situation. I'm a mobile app developer, and when I started working at AWS, I said, hey, all right, I want to publish an API for my mobile backend onto the cloud. And the first thing I go and I look at, all right, like what options do we have available? Go to Google, type in publish API to AWS, and was just immediately overwhelmed with all the different options and the weird names, and some services are called AWS something, and some services are called Amazon something, and what's an Elastic Beanstalk, what's a Fargate? I have no idea where to even start. So like any good engineer, I spent the next 2 weeks trying to figure all this stuff out, and the whole time I was just like, why isn't there something out there to do that has already done this for me? So hopefully, by the end of this talk, we'll all be experts on this. And the good news is, you don't have to worry about memorizing anything. You don't have to worry about taking notes, because I've done that all for you, and nothing's showing up on the screen. Let's see what's going on real quick. Oh, is it? Well, now that I messed it up, let's see if we can get it back. All right, 1 second. I know what's going on. All right, we're back. Okay, so like I was saying, don't worry about memorizing anything. You don't have to worry about taking notes. I mean, you're more than welcome to do it if you want to. But I've compiled all the resources from today's talk here at this URL. So you can scan this QR code. It'll take you to my website, codetraveler.io/compare AWS services. And that's where you can find all the resources we're discussing today. So that's where I've posted these slides. This session is being recorded, so once that recording is published on YouTube, I'll post it to the website as a direct link as well. And then for every AWS service we're going to cover today, I've gone through and grabbed the links to their Getting Started guides, and more specifically, also their links to creating web apps or APIs on that service. So whatever you find during this session, whatever you end up falling in love with, you got it. It's all there for you. And you're also welcome to share that with your friends and coworkers who maybe couldn't make it today, so that they also don't have to spend 2 weeks of their life trying to figure all this out. Now, before we get started today, I'm kind of curious with everybody here. Show of hands, who is currently running a website or an API on AWS? Okay, a couple folks, great. And if you don't have your hand up, perfect, you're in the right spot, because it'll save you all that homework from doing all the research. We're going to be covering a bunch of different services, and also kind of curious, who here is using containers? Show of hands if you like to containerize your applications. Awesome. Keep them up if you do it with Kubernetes. You like to do the orchestration yourself. You're a Kubernetes expert. Okay, we got a couple. Great. So the good news is Amazon's got you covered. We've got all sorts of services, and even more than we can cover today. We could probably spend a whole week talking about every service in AWS. But let's get into it, because today we're going to be focusing on these 10 services. So we'll be talking about Amazon EC2. We'll be talking about Lightsail, Elastic Beanstalk, ECS, EKS, AWS App Runner, AWS Fargate, AWS Lambda, and AWS Amplify. So again, if you've never heard of any of these before, they all have funny names. They all don't really mean anything, or do they? What does the 2 stand for? And EC2, why is that called Amazon EC2? And why is it called AWS Lambda? It's all part of the fun. But so if you've been confused by this, no worries. I was in that same space just a couple years ago. I mean, heck, sometimes I still am, depending on the day. But you know what? Even when I talk to folks here at the conference, even when I chat with fellow coworkers, we all can agree on one thing, and that's just choosing an AWS service is hard. We have what we think are easy requirements, right? It's like, I've got a web app, I've got an API, I just want to run it in the cloud. But then with all the different options that AWS has, it's been around for a long time now, and we keep coming out with more and more services for you that you kind of end up with that analysis paralysis, right? If you're greeted with so many different options, what are the different variables amongst each of them? Well, what we're going to look at today in our comparison are these considerations. So the first one we're going to be talking about, or the first consideration, is content type. So this is, what are you publishing? Is it a website? Is it an API? Is it a static website? Some of the services support both. Some of the services only support one. There's pros and cons to which one we choose. So we'll make sure to highlight which service is best for which content type. Automatic scaling. So probably one of the best features, or one of my favorite features of using the cloud is that if all of a sudden my app goes viral, I start getting a million active users all in one day, AWS can scale up to handle that. Whereas if we were running our own server in our own data center, that server would just get overloaded. All of our new users who wanted to give us more money and buy our services would then just be turned away with either like a 404 or a 500 error. But on AWS, we get automatic scaling. And specifically, there's two terms. There's vertical scaling and horizontal scaling. So with horizontal scaling, that's the automatic one. That's where, let's say we went to AWS and said, hey, AWS, I want to publish my website. And for that, I need a 4-core CPU with 8 gigs of RAM. And they go, great, we're running our website. Everything's going fantastic. Then let's say our app appears on the nightly news tonight, and all of a sudden we get thousands of new users. Well, with automatic scaling, what happens is once your usage, once that CPU usage, the memory usage gets above a certain threshold for a certain period of time, AWS will essentially clone that original instance, make 2, or it'll keep going, it'll make 3, it'll make 4 if they continue to be overloaded. And that's what we call horizontal scaling. So if we said we needed the server with a 4-core CPU and 8 gigs of RAM, and all of a sudden we're running up 100% CPU usage, AWS says, no problem, I'll double that capacity for you, and it'll make another instance also with 4-core CPU and 8 gigs of RAM, and then it will handle the load balancing for us. So we never really have to worry about our app going down because of overusage, but also important concept to keep in mind because, well, on the cloud, we pay for consumption, right? So if all of a sudden we have 1 million users using our website, well, we're going to have a hefty bill at the end of the month. But with automatic scaling, you can tweak some knobs. So you can say maximum 2 instances if you don't want to have to worry about paying a giant bill at the end of the month. But we'll talk about which ones have automatic scaling and which ones don't. Virtual machines. So all of these are running on virtual machines somewhere under the hood. And if you're not familiar with the concept of a virtual machine, this is essentially what created the cloud. If we go way back, back before the cloud, back before AWS is even a thing, back when we just had a bunch of servers and giant data centers to run Amazon.com, one of the Amazon engineers at the time kind of looked around and said, hey, you know what? There's a lot of servers we have that we've already paid for, but they're not running at full capacity. There's some CPUs, there's a lot of CPU cycles going wasted. There's a lot of half-used memory out there. What if we allowed people to essentially rent time on our servers? And so what they came up with was using the concept of virtual machines, where you can take a big, beefy server that, let's say you have a server that's got 32-core CPU in it, it's got 128 gigs of RAM. Well, with virtual machines, you can essentially chop that up into a bunch of mini servers. So we could take that one server, that one piece of hardware, and we could split it in half and have 2 virtual machines running on it. One virtual machine could be running Windows, the other could be running Linux. They don't know each other exists. All they know is they have, or they think they have, well, for all they know, the server they're running on has half of what the actual server does. So with virtual machines, we're essentially able to chop up servers into almost little mini servers. And depending on your needs, you might want control of that virtual machine. You know, maybe you want to dig really deep into the guts of the OS, or you need to access certain things in routing tables, or you're doing something crazy with IIS if you're a .NET developer, and you need those custom configurations, and you want to be hands-on with it, great. But maybe you don't. Maybe you're like me. I'm a mobile app developer. I've been making apps for almost a decade now for iOS and Android using C# with Xamarin and now .NET MAUI. And when I create a backend, I just want to throw it into the cloud and forget about it. I don't want to worry about scaling. I don't want to have to worry about the operating system, because if you do control the virtual machines, you're also responsible for it, right? So when those Windows updates come out, you have to be the one that installs those Windows update patches. Or when that 0-day vulnerability gets reported, you're the one, your Linux admin's going to have to go in there and patch it. AWS isn't going to do that for you if you choose to go that route. But there's also a lot of these services we'll be discussing today. AWS manages the virtual machines for us. So if you're lazy like me and you don't want to or need to manage that virtual machine, you can let the super smart folks that know security, know networking, handle all that for you. Or if you're on a bigger team and you have those requirements where you really need to dig into the guts of virtual machines, we also have those options available for you in AWS as well. Storage. Pretty self-explanatory. If you need to store files, logs, images, whatever your needs might be, some of these services come with storage, some don't, and you have to spin up a separate S3 bucket or storage instance in AWS. So just something to be aware of, whether it includes it or not. Probably the most important one, cost, right? Like I mentioned, I've been publishing mobile apps to the App Store, and I do it for fun. It's not my day job. It's not what I get paid to do at work, so I do it for fun on the nights and weekends. The apps I've published to the App Store, they're totally free. I've never made $1 off them. And so when I choose my backend that I want to be running in the cloud, cost is basically my biggest factor, because I can't afford $1,000 a month in cloud service bills. So when I went looking for my serverless, or when I went looking for my backend, I went with a serverless option because they are much cheaper, but there's trade-offs, and we'll be discussing what that means and which ones are right for you based on your needs. I just mentioned serverless. I've got a whole section later on where we'll dive into serverless. If you're unfamiliar with that word, with what that word means, or if you're unfamiliar with what the trade-offs and the penalties are with serverless, we'll explain all that later, because some of these are serverless, some of them are not. And then with containers, does this service support containers? Can I Dockerize my app when I publish it to the cloud? Or does it require containers? Do I have to containerize my app? Or how do I handle the orchestration? So these are all the considerations we'll be going through one by one on each service. And then there's also a bunch of common functionality that we're just not going to talk about. We're going to get it out of the way now, and that way we don't have to go over it every time when we look at each service. The first one being Windows and Linux support. So all the services we talk about today, they both support Windows, they both support Linux, so no matter which one you prefer or which one you need for what you're working on, you can do it. So we won't discuss that on each of them because they all support it. Vertical scaling. So a minute ago, I mentioned there's horizontal scaling. And remember, horizontal scaling happens when your instance starts to get maxed out. AWS goes ahead and essentially clones and load balances your instance. So it'll just duplicate what you've asked for. So that 4-core CPU with 8 gigs of RAM, it'll just duplicate it and load balance. With vertical scaling is where we go back to AWS and we say, hey, actually, you know what? I see that we're auto-scaling all the time. Like most of the day, I see we're running 2 instances of this 4-core CPU with 8 gigs of RAM, and I don't think we need to double it. I think we can get away with just increasing it a little bit. Maybe I just bump up that memory to 12 gigs, 16 gigs. And that way, instead of doubling and cloning that instance, essentially paying double the cost, you can do vertical scaling, which is where you just tell AWS, let's beef this up a little bit, right? Let's add a little bit more horsepower to this server and kind of keep that bill in check without having to rely on scaling up, scaling down all the time. Again, with the exception of serverless, which we'll explain later. And likewise, SDKs. So if you're like me and you're a lazy developer, which I like to say a lazy developer is a good developer, you don't have to rewrite any of these, any of the code to access these APIs. Now, if you want to, yes, all the services we cover today, they all have public APIs. If you want to do curl commands, if you want to get into C# and write your own implementation using HTTP client to access these REST APIs, you can do it. I don't. I wouldn't recommend it. My first question would be why. So the good news is, no matter what language you're working on, whether it's JavaScript, Python, .NET, Node, we've got SDKs for you. That's what I do in my apps. So when I have my API running in the cloud and it needs to pull a file from an S3 bucket, I just bring in the AWS SDK for S3. And basically, in one line of code, I can just say, await, get object async, and then I'm done. I don't have to worry about how do I implement these REST APIs and anything like that. So save yourself some time, save yourself some headache, and use these SDKs, because, again, they exist for all these services. OK, well, let's jump into it. This first set, we're going to be focusing on websites and APIs. So you're building a website, you're building an API. That's what we're covering in this section, with the caveat that none of these are serverless. We'll get into the serverless section in just a little bit. OK, so first up, we have Amazon Lightsail. Lightsail is a great way to get started on AWS. With Lightsail, you kind of get this all-in-one package where you get a virtual private server, it comes with storage, you get that compute power, and the best part about Lightsail is that monthly fixed cost. So you'll notice on these slides, I've done an estimation for you for your monthly cost, and estimating it around about 10,000 monthly active users. So it's never going to be exact. It's, in my experience, impossible to predict costs with cloud to the exact penny. You can get approximate, though. So what I've included on these comparisons is, let's assume you have 10,000 monthly active users. What would it cost? Well, for Lightsail, you can get away paying about $5 US a month. Now, the catch with Lightsail is it does not auto-scale. This is one of the only services we're going to cover today that will not auto-scale for you. But the trade-off is you know exactly how much your bill is going to be at the end of the month. Whereas when services do auto-scale, everything you do in the cloud, everything you consume, you pay for. So with Lightsail, you know that at the end of the month, if I spun up an instance that costs $5, my bill is going to be $5. So with Lightsail, it's pretty great. You get a little bit of storage included. You can Dockerize, you can containerize your app if you want. It's not serverless, and that virtual machine, Amazon's managing that for you. So those smart folks on the AWS team that keep track of all those security vulnerabilities and know how to do networking, they're going to do that for you, so you don't have to manage that. And kind of what I found, Lightsail is really nice for getting up and running really quick. So maybe you have an MVP you want to show off to your boss, or maybe you're just making an internal line of business app, right? Like maybe you work at a small company, you don't have that many employees, and only 100 employees are going to access this instance. Well, we don't have to worry about scaling. We know that the app's never going to go viral and get hit by 1 million users one day. So we can just kind of keep things simple, keep our bill simple, keep everything very, very simple with Amazon Lightsail. Now, the next one is Amazon EC2. EC2 stands for Elastic Cloud Compute. You'll see this a lot in the AWS naming. The numbers actually mean that there's more letters. And in this case, it could be ECC, but I guess EC2 sounds cooler. But Elastic Cloud Compute is essentially a virtual machine. And this was basically what birthed the cloud and was one of the original services with AWS. With EC2, you're literally spinning up a virtual machine in the cloud. You're going to AWS and saying, hey, I need to run Windows 11, and I want my server to have a 4-core CPU with 16 gigs of RAM. And with a couple clicks of the mouse, AWS will spin one up for you. You'll be able to access it. You can remote desktop into it. That is yours. You can do whatever you want with that operating system within the terms and conditions that AWS sets. Nothing illegal, but you can basically run that server as if it's in your data center. So the benefit here is you don't have to go buy a server. AWS will spin one up for you using virtual machines. But again, the catch is you're responsible for that server. So let's say you spin up an EC2 instance, and you're not really staying up to date on security patches. If somebody takes advantage of a vulnerability because you're too late to install a Windows update, well, that one's on you. So with EC2, you get a lot of power, a lot of control, because you're the one that owns that operating system. So if you need that fine-grained control to really go in there and maybe play around with routing tables or whatever it might be, you got that. But keep in mind that you're also responsible for everything on that server as if it's like a server in your data center. But the cool thing with EC2 is the elastic part. So when you hear the word elastic on AWS, what that means is it'll scale up for you. So that was one of the big innovations with cloud computing is not only can you get access to a server in just a couple clicks of the mouse instead of having to order one through procurement, wait for 6 weeks for it to show up, slide it into a slot in the data center, rack and stack it, do all that stuff yourself. You can have it up and running really quickly, really easily. But just keep in mind, you're going to have a lot of responsibility as well, since you are the one managing it. So with EC2, you do have, you are able to add storage to it. We have this tool called Elastic Block Storage, so you can choose how much or how little storage you want. And obviously, you can containerize your app to run it if you want, because, well, you own that server. You're essentially renting that server, that virtual machine from AWS every month. But let's say you like that concept of elasticity. You want that auto scaling, but you don't want to manage any operating systems. You don't want to have to worry about those security patches, or you don't care about routing and how to handle stuff like that on the operating system. Well, there's also Elastic Beanstalk. So with Elastic Beanstalk, it's actually pretty simple. It's kind of similar to EC2 in the sense that you go and tell AWS how much server you want. You'll say, give me a 4-core CPU with 8 gigs of RAM. But instead of getting direct access to a server where you can play around with the operating system underneath it, you can just tell AWS, hey, I want this running on Windows, and here's my code. So with Elastic Beanstalk, it simplifies a lot of the maintenance for you because you don't have to necessarily think about that underlying operating system. You don't have to worry about keeping up to date. You don't have to worry about the networking, the routing, any of that stuff. And you can essentially just focus on your code. And like I mentioned earlier, it is elastic, meaning it's going to scale horizontally for us. It comes with a little bit of storage for our logs and our artifacts. And again, if you want to containerize your app, you can absolutely do that with Elastic Beanstalk. And in fact, I recommend that. OK, ECS. So let's say you like Elastic Beanstalk, but you also love containers and you want to be in charge of that orchestration. ECS stands for Elastic Container Service. So think of it like it's Elastic Beanstalk, but you can be in charge of the container orchestration. So very, very similar concepts. You're going to go and specify how much server you want. You're always going to have that amount that you have on your monthly bill. It'll scale up, and scale back down to the original instance as your users demand. But a little bit of a difference here in your storage. So if you do need to store photos, logs, images, whatever, keep that in mind. You might have to spin up another storage instance. It's a little bit more expensive because, well, you get a little bit more features, a little bit more control. And likewise, you have to use containers with it. I mean, it's in the name, right? Elastic Container Service. And along with ECS is EKS. So there's Elastic Container Service. This is Elastic Kubernetes Service. So if you're a Kubernetes fan and you like everything about having all of your containers, but you want to use Kubernetes to do all the orchestration yourself, same. So EKS, you get the horizontal scaling. AWS manages a virtual machine for you. You don't have to worry about anything on the operating system level. And obviously, you get to take advantage of containers and Kubernetes. OK, so now let's talk about the serverless offerings. So this is also for your websites and your APIs. But all of these are serverless. Now, if you're unfamiliar with the term serverless, I agree it's a weird word. Like when I first heard of serverless, I was like, that doesn't really make any sense, because that means that my code's not running on a server. It's serverless. Like the server's missing, right? But we know that would defy the laws of physics. Like our code, it needs to run on a server. It needs a CPU. It needs memory. You can't just have no server and have your code running in the cloud. So the way I like to think about it, instead of serverless, I like to think about it as less server. So because the way serverless works is, instead of going to AWS and saying, hey, AWS, I need 8-core CPU, 16 gigs of RAM, with serverless, you don't specify anything. AWS takes care of all of that for you. So what ends up happening is you get instant scale. It'll scale up to meet your user demands. And then if nobody's using your app, like let's say all your users are here in Norway, it's the middle of the night, everybody's asleep, hopefully, well, it'll scale all the way down to 0. And what this means is your monthly bill is going to be a lot smaller, because if we were using something like Elastic Beanstalk, where I say, hey, I need to reserve an 8-core CPU with 16 gigs of RAM, well, whether you use that CPU or RAM or not, you're going to get a bill at the end of the month, because AWS has reserved that for you. Whereas with serverless, you're essentially allowing AWS to scale up and scale down, and even all the way down to 0, where you're not actually consuming any cloud compute when your users aren't using it. So serverless is one of my favorites. Like I mentioned, it's what I use for my mobile backend, because I need to save some money, right? But there is a catch. There's always a catch. You don't get something for cheaper without there being a catch. And that is the concept of cold start times. So with serverless, because your instance will scale all the way down to 0, when that first user wakes up in the morning and they go to your website, AWS is always listening. It's always waiting for that HTTP request, that GET, that POST, whatever is inbound, whatever that event might be. AWS is always listening, so no worries there. But because it's not actively running on a server, when that first website request comes in, AWS has to quickly spin up some resources for you. And as you can assume or imagine, that takes some time. It's not instant. It's pretty quick. But that's what we call a cold start penalty. Now, I've been using serverless for years now, and back when I started using serverless, back in my day, the cold start times were 1, 2, sometimes 3, sometimes 5 seconds. It could get painful, and I had to do a little show just to distract the user. Like if you ever launch my apps, I still have it in there today. You'll see a little animation when my app's loading to kind of distract the user, so they're not just sitting there looking at a blank loading screen. Because back then it might take a couple seconds for the app to initialize. Nowadays, though, this is a chart for .NET. I'm a .NET developer, so I'm biased. So here's my numbers on .NET. If you're using the latest version of .NET, which is currently .NET 8, and you're following all the best practices using native AOT, then your cold start times are really going to be closer to about 300 milliseconds, which I don't know about you, but for me, I'm not worried about 300 milliseconds. 300 milliseconds is literally how long it takes someone to blink their eyes. So in the blink of an eye, I can go from 0 to up and running as soon as somebody goes to access my website. So nowadays, not too much of a big deal, but there's definitely certain scenarios where that 300 milliseconds can be really bad, really dangerous. Like I think about probably mostly financial transactions, or maybe you have an app that uses or makes stock trades, right? So a user comes in and says, I want to buy 1 million shares of stock for $100 a piece, and then they click send or go or submit, whatever the button says. They click the button, and then 300 milliseconds or an additional 300 milliseconds go by. That stock price went up by $1. Well, you just guaranteed them that you could buy all of that for $100 a share, and now you have to eat that extra $1, which if you're buying 1 million shares, you just cost the company $1 million. So they're kind of far-fetched scenarios nowadays where 300 milliseconds might be a problem in your business, but this is what we want to keep in mind. Like I said, serverless does end up being a lot cheaper. It's a really nice option. I love it. For my mobile apps, I don't have to worry about any financial transactions or anything crazy like that. But definitely something we want to keep in mind. That being said, with serverless, there's also warm starts. So when I'm the first one to wake up in the morning, I go to the website, I'll get hit with that 300 millisecond cold start. But let's say you wake up 5 minutes later, you hit the website, well, that instance is already warmed up. That CPU that is already up and running, so you'll be greeted with what's known as a warm start because, well, I went through the pain of the cold start for you. And in our experience or in our data, we see that on average, about 70 to 80% of users using serverless on AWS actually experience warm starts. So the majority of your users will still get a warm start time. But again, cold starts are going to happen. It's something to keep in mind. Is that important? Is that going to impact your business? Or is it not a big deal like, like for me? But also keep in mind, this is, like I said, following all best practices. There's always ways that we can write bad code. If we do a lot of initialization on our server when our code's spinning up and we're doing some long-running processes that take a couple seconds, well, then your cold start time is also going to take a couple seconds. So keep that in mind. But for the most part, serverless is a great option. And that brings us to AWS Lambda. So Lambda is basically the original, the OG serverless offering. I believe it was first, and many will say it's still the best serverless offering out there amongst all the clouds. And right away, you can see why it's my favorite, because for 10,000 monthly active users, it's basically free. Now, again, not guaranteed to be free. I've got some asterisks here. There's small print, so if you squint your eyes and you look closely, I've put the numbers here. The free tier on AWS Lambda gives you 1 million free requests per month. So if you keep under 1 million requests, you're good. And like for my mobile apps, they're not huge. I've got a couple hundred monthly active users. My average bill ends up usually being about 10 to 20 cents so 10 to 20 US pennies. So easily affordable on my $0 a month income. But yes, if you go above the free tier, above 1 million free requests per month, then we get into even more fine print down here where it's now going to cost you a whopping $0.00013 per gigabyte second, and then an additional 20 cents per million requests, which that's still really, really cheap. So with AWS Lambda, again, because it can scale all the way down, it only have to pay for what you consume. With serverless, you're not renting CPU time indefinitely. You can really cut back on a lot of your costs. So again, highly recommended if you can keep in mind those cold start times. And so obviously with auto scaling, it's going to do horizontal scaling for you, no problem, because it always will scale up and scale down based on your user demands. It's basically free for 10,000 monthly active users. It's serverless, and of course, you can also use containers if you want to, say, Dockerize your application before pushing up to AWS Lambda. There's also AWS Fargate. A better way to think about this is as ECS or EKS serverless. So Fargate, under the hood, uses ECS, the Elastic Container Service, or EKS, Elastic Kubernetes Service. It's essentially your serverless container service. So similar idea. It's just using those under the hood. But again, you're not renting that time on the server. You don't have to pay that fixed price per month, whether you use it or not. You get the benefits of scaling up and scaling down. But yes, you do have to use containers, and yes, you're going to have to know how to do all that orchestration and work with it just like with ECS or EKS. And then lastly, for our last serverless instance here is AWS App Runner. This one's pretty cool because AWS App Runner is, or rather, the way AWS App Runner works is instead of me building my code on my machine, publishing it, then shipping that up to the cloud, with App Runner, I can point that at my Git repository. So I can point it to my repo in GitHub. I can tell it to watch a specific branch. And then anytime there's a new commit to that branch, so if I tell it to watch the main branch, every time I have a pull request merged to main, well, AWS App Runner will automatically build my app and redeploy it to the cloud. So it's great. It's kind of like the lazy man CI/CD pipeline. You get serverless offering, and you get continuous integration, continuous delivery, all included. So again, if you're like me and you don't have a team of engineers working on your app, if it's just you, AWS App Runner is a really cool solution where now you don't have to worry about building a CI/CD pipeline. AWS is going to take care of all that for you. And it is serverless, so you get to take advantage of all the scaling up, scaling down. With serverless, again, Amazon manages all the virtual machines and operating systems under the hood for you. So this is really almost like a set it and forget it, right? It's just like, hey, watch my GitHub repo, and then anytime I make a commit, make sure to republish my app. Really, really cool stuff. OK, now let's talk about static websites. Everything we've been talking about or focusing on so far is what we would call dynamic websites, whereas a static website or a SPA, a single-page application, is something where the user doesn't really necessarily interact with anything. Kind of think about it like my website. If you go to codetraveler.io, it's just a blog. It's a place where I share knowledge, share information. I write articles. I write helpful stuff on there for you. So a static website is something that's kind of a really simple website. And if you have one of those, then the good news is you can take advantage of some really, really cheap options. Like one is you can actually host it in Amazon S3. Now, S3 stands for Simple Storage Service. And when it was originally created, and still is just an object storage. So I use this all the time. You can upload photos to it. You can upload files to it, then have access to those photos and files, JSON blobs, whatever it might be, from anywhere around the world. And so if you think about your static website, if it's just HTML, CSS, JavaScript, you can essentially upload that to S3, so upload this to almost like a folder in the cloud, and then you have a URL pointing to that start page on your website. Well, when anybody navigates to that URL in the browser's going to pull in all that HTML, all that CSS, all that JavaScript, and it knows how to do it. So you don't need necessarily an operating system running, which is why here I say for virtual machines, technically, it's running on a server somewhere. That server's running a virtual machine, but there's really no virtual machines involved in the sense that you got to keep Windows up to date. It's essentially, again, just like a hard drive in the cloud, a folder in the cloud where we're storing our website. Now, there is some caveats here because, when S3 was created, it wasn't necessarily like, hey, let's make a static website hosting service. It was kind of something folks figured out later. It's like, we could take advantage of this, and what, $5 a month for that? Yeah, I'll happily pay that. So if we look at the fine print here, the limitations, because there's really no auto scaling when it comes to this, but S3 does have a ceiling on how many requests per second it can handle. So for S3, we have 3,500 put, copy, post, and delete requests per second that it can handle, or 5,500 get requests per second. So for static websites where all we're doing is making GET requests, if you don't need any more than 5,500 requests per second, you're good to go using something like S3. Now, something else we want to keep in mind if we're going to go this route with S3 is, yes, we have a public URL that we can share, but that URL is going to be kind of nasty. If you look at it, that URL will look something like us-east.aws.amazon.com/S3 with a long GUI attached to it. It's not going to be a pretty URL. I'm not going to, I would be a little embarrassed if that's the website I share. It's like, oh yeah, here's my website, and it's 70 characters long. So with hosting your static website in S3, it's definitely a good practice to take advantage of a couple of the other AWS services. Like we have AWS CloudFront, where You can provide your own DNS, provide your own website URL, so you can customize that. It'll make sure everything gets routed properly. Or let's say you have users all around the world, right? People all the way in Australia are reading your blog. Super, super cool, right? But if we're hosting that S3 instance here in Europe, that means every time that user in Australia navigates to your website, that request goes all the way around the world to the data center in Europe, and it's got to come all the way back. So if you want to do something like edge caching, you might want to add in some CDNs there. Again, depends on how heavy is your website. Do you have a lot of images? Is it better to keep those at the edges of the network, edges of the internet, so to speak? Or if it's just a bunch of text and colors and maybe just vectorized images, then you probably don't need to do that, but all things to keep in mind. So again, only for static websites. You can get away with paying a pretty cheap fee every month, but keep in mind these limits on the GET requests, the POST requests, because you might, if your website gets super popular, you might end up needing to shift over. And for something like that, we could go to AWS Amplify. AWS Amplify also supports static websites. Technically, it does also support dynamic websites. So that's our fine print at the bottom. Is if you want it to, under the hood, Amplify can take advantage of other services like Fargate to run a real, more dynamic website. But the nice thing with AWS Amplify is that if you have more needs, like you have to do authentication on your website. So for that, at AWS, we have a service called AWS Cognito, where we can handle user logins. Well, AWS Amplify comes packaged with that. So yes, your website's still static. It's not super complicated. You don't need to overpay for all these servers. But with Amplify, you get a little bit of more of an all-in-one bundle. And then maybe this is a growing business, right? We've just created our first website, but we know we're going to add stuff to it in the future. Maybe we're going to have user profiles and authentication, and we're going to allow people to upload their profile pictures. And we've got big plans for our website, right? Well, the nice thing with AWS Amplify is it can grow with you. So if you need to kind of go from static to dynamic, you can do that. If you need to add in authentication, you can do that. Whereas if we started out with S3, then we'll have to migrate over and do a little bit more work. So AWS Amplify, also a great option. Again, you can containerize your app. It is serverless, and it can use other services under the hood if you do want to continue growing and continue building your application. Okay, so I know I've thrown a lot of words at you, a lot of acronyms, a lot of numbers, a lot of details. So what I want to do is a quick review, basically boil down everything that we've discussed so far, and hopefully a nice, easy-to-read chart. So all the way on the left here, you have our self-managed, if we want to have virtual machines, if we want to really take advantage of having that real fine-grained control, right? Because remember with EC2, Elastic Cloud Compute, that's where we get a virtual machine. So again, you're responsible for that operating system. You got to install those patches. You got to make sure it stays up to date. You got to do the routing table. You got to do all that fun stuff. But also, you have the ability to do all that fun stuff. So if you do have a team of engineers and you're looking for your first shift to the cloud, these are great options. You spin up the virtual machine, and then you can kind of throw away that server that's in the data center because you don't need to manage it anymore because you got this taken care of for you. It's elastic, so it grows up and down, meets all your needs. There's also Lightsail. So remember, that's where I said is simple solution, easy to get started, but keep in mind, Lightsail is not going to scale for you. So make sure you know your user demand ahead of time so that you don't accidentally overload your server and start having angry users yelling at you because the website's down. Because with Lightsail, you have a fixed monthly cost because it doesn't scale up, scale down. So again, I like to think of that for maybe internal line of business apps where you know you're never going to have 1 million users or 1 million requests a second, or for something like just a quick MVP, your boss says, hey, what's this cloud thing? Let's try it out. Show me something cool in the cloud. Then you can spin up something in Lightsail. If you don't want to manage those virtual machines, we take a step into Elastic Beanstalk. Again, it's not serverless. It's where we specify that we want every month, we're going to be paying for a 8-core CPU with 16 gigs of RAM, whether we use it or not. You know, if nobody accesses our website all month, we still get a bill at the end of the month for reserving that CPU, that memory in the cloud. But the benefit there is you don't have to worry about the serverless downsides of cold starts. That app's always going to be up and running. So if it is something critical where it needs to load right away, you can't risk that 300 millisecond cold start. Elastic Beanstalk, great solution. It also scales up, scales down. If you want to do that, but with containers, you got ECS, Elastic Container Service. You've got EKS, Elastic Kubernetes Service. And if you want to keep going and jump into the world of serverless, we have options like AWS App Runner, which, again, you point to your GitHub or your Git repo. It supports GitHub, Bitbucket, a couple different options. And anytime you publish domain or push a commit, merge a pull request, it'll automatically build, deploy your app. Do keep in mind, you do have to tell App Runner what you're using, right? So for me, I would go in and say, hey, I'm using .NET 8. Here's that specific SLN file for my solution that you're going to build and deploy. And so when .NET 9 comes out, before you go upgrade your code, commit it, merge a domain, don't forget about App Runner, right? Don't forget to go tell App Runner, like, hey, run a new version of .NET now. Serverless containers is also Fargate. Fargate, again, it's ECS, it's EKS under the hood, but serverless. And then all the way on the end, my favorite, AWS Lambda, where you don't have to worry about anything. You don't reserve any space in the cloud. You basically get to run for free. But again, with the caveat of the free tier does eventually run out. So remember what, or keep in mind what your user expectations are, and then also keep in mind cold starts. How do you handle that? Is that impactful for your business? Will your users even notice 300 milliseconds? Maybe, maybe not. But like I said, it's my favorite because that nice bill at the end of the month. And then if you have a static website or a single-page application, we also have a couple options for those. So again, there's S3 all the way over here. It gives you a little bit more control where, again, it's basically just a folder in the cloud, just a bucket where you can just put files. But you can put your website in there, and then we can bolt on services. So you can customize it using something like CloudFront to add in a custom URL domain, or there's API gateway where we can essentially add on to this and leverage these other resources. But it's real cheap, real easy way to get started for our static websites. And also amplify. So if you foresee that website growing, if you're going to add more features in the future, or you know you're going to have to do authentication and add in logins for users, well, then Amplify is a great place to start for your static website because it can become a dynamic website using instances like, or services like Fargate under the hood. And it comes prepackaged with Amazon Cognito, which we can use for authentication. OK, if you haven't had a chance yet, now's the time to take out your phones, grab a picture of this slide, grab this URL, because, again, this is where you can find all the resources from today's talk. So this is where I've posted the slides. When this video gets published up on YouTube, I'll post a direct link to it there. And then for every resource we've covered, I've gone to the AWS website and grabbed those getting started guides, and also the specific guides for working with web apps for each service in the cloud. These were all resources that were super helpful for me when I was learning how to do all this stuff in AWS, and I know they'll be helpful for you too. Thank you.